Hey y'all! Welcome to the 9th episode of Space Telescopes, a fully dedicated series for tweets and observations from space. All links to articles, images and videos used here are available in description. Before going further, have you watched the recent video from Smarter Everyday YouTube channel? In this, he talks to astrophysicist, cosmologist, Nobel laureate, senior project scientist for James Webb Space Telescope, Dr. John Mather. Watch till the end of this video. You will be reminded again.
So each of them is made out of beryllium, which is very light and very stiff and holds its shape when it's cold. That was our hardest thing, to learn how to make them ultralight, because each of these hexagons is something you'd be able to lift with your hands if we'd allow you to do it. So they're really thin material and really, really accurate.
NASA Universe. CuPID and CuPID are two among four CubeSats that hitched a ride along with Landsat 9 aboard Atlas V last week. CUSP Plasma Imaging Detector, or CuPID, will observe the effects of solar wind interacting with Earth's magnetic field, while also helping us understand distant objects like stars and pulsars. CuPID principal investigator Brian Walsh, admiring the satellite. With around 20 confirmed satellite galaxies, scientists think there might have been others that lost their gas and stars to Milky Way's gravity. What do you think of Milky Way? Did you already know about the contributions of space industry and the agencies to our everyday lives? Well, here's another one. Miniaturized high-speed modulated X-ray source, made for nicer telescope aboard International Space Station, could make CT scans more accessible and thus cheaper. As a small galaxy cluster passes Perseus galaxy cluster at a distance, even with 1/10 of its mass, creates a huge disturbance at the center containing cooler gas. This forms huge waves at its periphery that would last for hundreds of millions of years. Breathtaking. Astrophysics Stratospheric Telescope for High Spectral Resolution Observations at Sub-Millimeter Wavelengths, or ASTHROS, is a high-altitude balloon mission, expected to launch in 2023. At an altitude of 40 kilometers or 24.6 miles, carrying 2.5 metric tons, it will help collecting far infrared light and help study a phenomenon called stellar feedback. Finding the unexpected is common when you have an unexplored universe to look at various wavelengths. Find what unexpected discoveries came out of gamma-ray exploration, such as black widow pulsars and ghostly neutrinos from outside our galactic neighborhood. Magnetars are neutron stars with extremely strong magnetic fields. At about the size of an average city, if one were to be placed halfway between Earth and Moon, it would wipe clean the data on all magnetic strip credit cards around the world. Even at 1,000 kilometers, its magnetic field is so lethal, it could tear you apart by distorting the electron clouds of your atoms. Hubble ESA. Located at 130 million light-years from Earth, NGC 5728 is a safer galaxy. Captured using Hubble's Wide Field Camera 3, which is only sensitive to visible and infrared light, this image shows only part of the emitted radiation. This galaxy is powered by the energetic active galactic nuclei, AGN, at its center. How would you do weathercasting on a planet hundreds of millions of kilometers away? With the help of Hubble's decade-long observation, scientists have noticed about 8% increase in wind velocity at the outer lane of Jupiter's Great Red Spot. Without the decade-long observations by Hubble, these kind of discoveries wouldn't have been possible. The lead researcher on this discovery, Michael Wong, used software to analyze millions of wind vectors each time Hubble was pointed at Jupiter. The change in wind speed was so small that, without the decade-long data, we wouldn't have noticed it. In this video, you will see a time-lapse of the Great Red Spot, for the duration of one full Jupiter day or 10 Earth hours, played in a loop. It is seen as if it were illuminated throughout the day. Captured using Hubble's Advanced Camera for Surveys, or ACS, this image shows NGC 4522. which is being stripped off of its gas by a phenomenon called RAM pressure stripping. This galaxy is part of the Virgo galaxy cluster. The image featured in ESA Hubble Calendar 2021, for the month of October, is a region of space called LHA 120N150. It is a substructure of the gigantic Tarantula Nebula, which is situated more than 160,000 light-years away in the Large Magellanic Cloud. Hubble Space Telescope. Huge clusters of galaxies warp the fabric of space with their extreme gravity, bending light towards Hubble. This allows astronomers to see galaxies in the early universe that otherwise would be too far to detect, even for Hubble. Known as 3C321, this is a system of two galaxies orbiting each other. Both contain supermassive black holes at their center, of which, the black hole in the larger galaxy is producing powerful jets. Showing the smaller galaxy in the path of the jet, this image was produced by a combination of visible, infrared, X-ray and radio observations, made by space and ground-based telescopes. Hubble NASA. Sonification of cosmic data is always a treat to our ears. NASA Hubble shared the sonification of Milky Way's center for the International Music Day. Enjoy! With a touch of blue star-forming regions in the edge, this oddball galaxy NGC 4622 rotates clockwise, with spiral arms wrapped around in the opposite direction. It is located at 111 million light-years away in the constellation Centaurus. NASA Exoplanets. Neptunian exoplanets are similar in size to the ice giants of our solar system, Neptune and Uranus. These exoplanets typically have hydrogen and helium-dominated atmospheres, with cores made of rock and heavy metals. Since these exoplanets orbit far from their host stars, so-called hot Neptunes are rare to find. A hot Neptune was discovered this year at a distance of 1,600 light-years from Earth. With almost 6 times the mass of Earth, it orbits its host star similar to our Sun in about 6 days. It orbits the star 16 times closer than Earth orbits Sun. Chandra Observatory. The image of supernova remnant G327.1, 1.1 captured by Chandra, shows outward-moving shockwave in red, and pulsar wind nebula in blue. An asymmetric supernova explosion may have given a recoil kick to the pulsar, causing it to move rapidly, and thus producing the lobster claw-like features seen in red. Our Milky Way galaxy is not an island universe, but a member of a small cluster of galaxies called the Local Group. The Local Group contains about 3 dozen known galaxies, clumped in 2 subgroups around 2 massive spiral galaxies, the Milky Way and the Andromeda. As Chandra observed a galaxy cluster in the constellation Grus, the Crane, nearby was the barred spiral galaxy NGC 7424. A rare, Type 2b supernova was observed on the outer edge of this galaxy, on the 10th of December 2001, by Australian amateur astronomer Robert Evans, who also holds the record for 42 visual discoveries of supernova. NGC 7027, also called the Jewel Bug Nebula, is a bubble of 3 million degrees Celsius or 5.4 million degree Fahrenheit gas that is about 700 years old. Located at 3,000 light-years from Earth, it is small for a planetary nebula, but still, it's 55 times larger than our solar system. ESA XMM. If you have a proposal for ESA's XMM Newton observation, October 8th is the last date. Hurry up! Also, ESA has opened applications for Archival Research Visitor Program. Visit the link in description to find more information about it. Athena X-ray Observatory. The heart of detector electronics of the Wide Field Imager used in Athena Observatory is formed by a frame processing module, FPM, which digitizes and processes all analog output signals of the camera head. The photo shows a prototype of the FPM hardware based on field programmable gate arrays. ESA Euclid. ESA's Euclid telescope, set to launch by the end of next year, has crossed a major milestone by passing a critical test lasting 60 days in vacuum, at -150 degrees Celsius or -238 degrees Fahrenheit, at Centre Spatial de Liege in Belgium. Watch the following video, showing the telescope being uncovered from its vacuum tent. Nancy Grace Roman Space Telescope. Another great news. The Roman Space Telescope, set to launch no earlier than 2027, has completed a major milestone by passing the critical design review, meaning all design and development engineering work is now complete. With 200 times the field of view of Hubble, Roman can take sky surveys that would take hundreds of years with Hubble. Webb Telescope, ESA. ESA's Near-Infrared Spectrograph, or NIRSpec, is one of the 4 instruments on Webb. It will provide low, medium and high-resolution spectroscopic observations in near-infrared. Watch the YouTube video to understand the path of light as it travels through this instrument. Mid-infrared instrument, or MIRI, is another of the 4 instruments on Webb that observes in wavelengths ranging from 5 to 28.3 microns. To understand the path of light through this instrument and its operations, watch the YouTube video by ESA. Space Telescope Science Institute. Being just a couple of months away from the launch of James Webb Space Telescope, we might have a lot of questions. Expect a short video, containing Webb fast facts from this thread, by the end of this week. We know, Webb will observe and study outer solar system objects. But in what way will it explore our planetary neighborhood? Webb will help verify the previous studies on Martian atmosphere. It will help study the atmosphere of gas giants at various depths, and their moons with finer details than previously possible. Check out the article to know more. Final reminder, don't forget to watch this interesting video, if you want to know more about Webb. That's it for this video. Thanks to these engineering marvels, opening windows to the universe, and thanks to you friends for your patience. See you next week.